and welcome to Maths with Millie. Give a wave, Millie. Millie! So, I'll get in focus now. At least I've got the dog in now. Right. Still not quite in focus. We'll be in a second. There we go. Right, so today I'm going to go over, it's upside down, isn't it? Give me 1 second. See, this is comedy value, this is. That's the right way, isn't it? Yeah. See, there's a reason I don't teach ICT. Hopefully I will get better at this. In about 10 years' time, I'll be almost efficient. It's meant to be backwards. Okay. No, it is meant to be backwards, and then when they watch it, it'll be the other way around. It's a mirror image. Right, anyway, continuing on. Right, just consulting my technical advisor there. Right, so yeah, paper 3 on the practice set that you've been given to do over the holidays. Not to hand in, but I just thought I'd go through it anyway. So question 1 is asking for the gradient. Your gradient is your up distance over your across. You may know it as your rise over run, or you're changing your y's over your changing your x's, or y2 minus y1 over x2 minus x1. So I've dropped in my right angle triangle using what I call snap points here. Just 2 really easy points to read. And I've taken my up distance, divided it by my across distance. So it's 3 over 2, 3 over 2 is 1.5. You could leave them either way, it would be absolutely fine. It's a positive gradient as well because it's sloping upwards, just always watch out for that. If it was sloping in this direction, it would have a negative gradient. Question 2 is a frequency polygon. We had one of these earlier. When you draw a frequency polygon, you need to take the midpoint of each class interval. So I've got the halfway point between 0 and 10, 10 and 20, 20 and 30, 30 and 40, 40 and 45. You can see them down there. And I've plotted them with my frequency. Now these length of time ones, they go along the bottom axis and the frequency is up the side. So I've plotted 5 and 6, 15 and 9, 8 and 25, 35 and 7, 45 and 5, and I've joined them up with a straight line using a ruler-ish. Question 3, Henry and his water meter. You need to decide which one is the best value for money out of the two. So there's either no water meter or for £107 a year, or the water meter. He uses 180 litres of water each day. What you have to do is compare a year on one plan for a year on the other plan. So 180 times 365, that's the amount of water that he uses a day, not a day, sorry, a year, in litres. If I divide that by 1,000, I get 65.7 cubic metres, so that's his use per year. I've used that bit there to do my conversion. If I times that by 91.22 pence, I get this figure here. Remembering that answer is in pence, so if I divide by 100, I can convert it into pounds. Adding on my standing charge of £28.20, I get £88.13. Putting those two now comparing back to this one, it's cheaper for him to have a water meter fitted. Moving on to question 4, Kalinda and her electricity. Use the graph to find out how much she pays each month. We're looking for the gradient here, so your up distance is 15 divided by 60, so that's 0.25, so that's 25 pence. Remember that your gradient represents your rate of change, so it's the change in cost per change in units. So the change in cost per extra unit of electricity, that's your gradient there. You can see here as well that the gradient is steeper here than it is here. That means it's more expensive here per unit than it is here. Then they start talking to you about tariff B, if it would be cheaper to move on to tariff B. Tariff B is just 20 pence per unit of electricity. they tell you that she uses 90 units of electricity each month. So if you do 20 times 90, you get what she'd pay for tariff B. Read off tariff A from the graph for 90 units, and you get that it's £19. So yes, she should change to tariff B because it's cheaper. This next question, David in his garden, you need to work out the area of the grass. So we've got three shapes here, A, B and C. The first two are triangles. Don't forget to divide by 2 when you're triangles. The first time I did this I forgot. I thought my answer looked a little bit strange. And don't forget your units for this as well. So base times height for your triangle, 12 times 25 divided by 2 gives you 150. Repeating that for B, 11 times 25 gives you 137.5. Shape C is a trapezium. Now the formula for a trapezium is a half A plus B times H. A and B are the parallel sides and H is the perpendicular height. So we've got a half of 15 plus 6 times 25. So a half times 21 times 25, which gives us 262.5 feet. Adding those three values together, 550 foot squared. And just don't forget to put your units in on the end there. Here, indices, the rules of indices, when we multiply we add. So that would be p to the 9, 5 plus 4. When we divide we subtract the powers. So that would be q to the 3, 5 minus 2. Here, 12 divided by 6 is 2. That's t, and t will cancel out. And then I've got u to the 6 divided by u to the 5, so that would just be u. Simplifying this, 9 to the half is 3. Multiplying the powers because of the brackets, so a half times 2 is 1, so 3w, and then y to the 6 to the half would be y to the 3. You can think of that 9 as being 9 to the 1, so 1 times a half is 9 to the half. 9 to the half means the square root of 9, and the square root of 9 is 3. Now we need to order these. They say x is greater than 1 for the following expressions, write in order of size. So I'm just going to pick an easy number to try and figure out what these values are and substitute it in. It's the easiest way. So I'm going to say that x is 2. So if x is 2, 2 to the 0 would equal 1. 2 squared would equal 4. That one there would equal 2. X to the minus 2, that's the same as 1 over x squared, so that would be 1 over 4. This one, x to the half, square root of 2. Now that's approximately 1.4. So putting them in order, the largest is x squared, followed by x. I'm just going to cross them off when I've used them. The next one is this one here, x to the half, then x to the 0, then x to the minus 2. I'll do questions 7 and 8 and then I'll stop. So we've got 3 cubes here. The volume of cube B is 20% less than the volume of cube A. The volume of cube C is 20% less than the volume of cube B. Cube A has a volume of 8,000 centimetres cubed. So if I want to find cube B, I need to find 80% of that, 20% reduction. So 8,000 times 0.8 6,400. So that's the volume of cube B. The volume of cube C is 20% less than the volume of cube B. So cube C is 6,400 times 0.8. So I'm finding 80% of it, doing a 20% reduction. That's 5120. What is the volume of cube C as a percentage of the volume of cube A? So I need my cube C divided by my q(a), times it by 100 to turn it into a percentage. And that gives me 64%. Question 8. In a sale, normal prices are reduced by 15%. Janice buys a computer in the sale and she pays £578. Work out what the normal price of the computer is. So that £578 represents 85%. Now, there's a few ways to do this. The quickest way is to say, well, that as a decimal is 0.85. If you were working out 85%, you would times by 0.85. That's what they've already done, so we're going to reverse that process and divide by 0.85. I'm going to do that over here, actually. So 578 divided by 0.85 gives me 680. However, if in an exam you forget that, what you can do is work out what 1% is by dividing both sides by 85. And then figure out what 100% is by timesing that by 100. And there you go. Got the same answer. £680. You can double check that as well. 680 is going to be times 85%. Yeah, that works. There we go, and done. I'll come back with the next instalment later. Thank you.